A very good morning, students. Today we are going to start the second lecture of the solid state, and that is unit cell and its type. Okay, so here we will in that previous video, I have explained about that what are the lattice point and how they comprise, how they form the unit cell. Okay, so in this case we are going to study about its type. Let me again explain this unit cell. Unit cell is the small portion. This is a small portion of the space or the crystalline lattice is known as unit cell. That means if we talk about any solid, it is made up of infinite number of unit cell in that. Okay. So let's start with this type. So before that, let's do this characteristic of unit cell. Characteristic of unit cell, already I have explained that each point in a lattice is known as lattice point or lattice site. And if we combine this lattice point or lattice site, they are going to form a unit cell. Okay. This point may be an atom, molecule, or ions. It can be. How it is, I will explain it later on with the form of example. We will do it. Okay. Then lattice point are joined by straight line to give a geometry of lattice. That means if they are simply like square planar ho sakta, they can be rectangular, they can be rhombus, they can be parallelogram, like this. Okay. Now if you see that this is the unit cell and this is the complete lattice structure and this is the unit cell, one part. I hope it is clear. This one part is unit cell and the complete to be a dots dikh rahe hain, that all are the lattice structure and that is called the lattice structure of a solid. Okay. Parameters of unit cell, already I have explained about you that there are the 6 parameters. That means 6 the side length ABC and that 3 edges ABC and the 3 angles between alpha, beta and gamma. Between them, that will be alpha, beta and gamma. So 6 parameters are there. Dimension along the edge of the unit cell is represented by A, B and C. This is the dimension along the edge of the unit cell is represented by A, B and C. That means X, Y, Z axis, you can say. Unit of edge of unit cell may or may not be mutually perpendicular. It depends. Agar ye cubic hoga, to obviously all the 3 will be mutually perpendicular. But if it is not cubic, so this angle will not be 90 degree and hence they will not be mutually perpendicular. I hope it is clear. The angle between B and C is represented by alpha. Between A and C is beta and between A and B is gamma. This is the angle, all the angle represented. That means B and C, if we explain that B and C, it will be alpha. A and C, it will be beta. And A and B, it will be gamma. Clear? Okay. Now the types of unit cell. Types of unit cell, there are the 2 type of unit cell. One is called primitive, another is called centered unit cell. Primitive ka matlab, only the lattice point will be only at the corner. And this is centered. Centered karne ka matlab, that along with the corner of that unit cell, somewhere else also be that kisi na kisi part ke center mein hoga. Got it? So let's see. Primitive unit cell, if I am talking about, this is when the particles in the unit cell are present only at the corners. Okay, then it is called primitive unit cell. Centered unit cell, when the particles are present at other position in addition to those at the corner. That means corner are not going to anywhere. Corner will be there. Along with that, some other site also that lattice point is there. Then it will be called centered unit cell. Let's do an example. Like we can see that primitive unit cell only at the corner. You can see 4 parts. You can see that means it is the 1/8 of one atom, isn't it? 1 cubic cell it is. And जो part red वाला part दिख रहा है, this is the 1/8 part of a sphere. Yes. Now let's do about the centered cubic cell, centered unit cell. There are the 3 type of centered unit cell. The first is called body centered unit cell. That means along with the corner, the particle one particle will be at the center of the body. Body के center में जो unit cell होगा उसके center में होगा. Got it? As for example, I will show you with the like 3D example. Next, face centered. Here, as the name suggests, face centered. How many faces we have in the cube? How many faces? There are the 6 faces. So along with the corners, each like center of the each face also that particle will be there. Got it? So if one constituent particle lies at the center of each phase beside the particles lying at the corner, then it is called phase center. And center, and center, that means if it is like, we can say that opposite phase mein, or we can say that the alternative phase. Okay, if we talk about the alternative phase, that also end center. If one constituent particles lies at the center of any two opposite phases, okay, that is along with the corner is not going some anywhere, I have told you so many times. Okay, it is known as end centered unit cell. It is also known as base centered, and it is also known as alternative like unit cell. Okay, that means the particle will be at the alternate phase. Kaise hoga? So just think of it. Let me show you with the diagram. Next thing, there are the 7 types of unit cell formed, that is cubic, tetragonal, orthorhombic, monoclinic, hexagonal, rhombohedral, or trigonal and triclinic. So out of this, mainly we have to focus on this cubic. और यही आपको पढ़ना है. This is in our syllabus. Okay. Okay. This one, as I told you, let me show you with this diagram. In this case, it is moving, so I have to make it fixed. Then only let me show you the another one. Okay, if I'm saying like this, this is body center, don't just forget about it. इसे भूल जाओ, ठीक है? Only at the corner, okay? Only at the corner, and along with this, I said that here, it will be here, okay? And at this, oppositive faces, okay? Opposite faces are there. So how they are known as alternate phase? Let me show you. Like if I'm going in this way, except this next, if I'm going in this way, this vertical wala we will leave the edge face, and here if I'm coming in this way, ye is tarah se aa raha, so this phase is going to be blank, and then in the bottom it will be. If I'm going in from the back side, so this phase will be blank, which is at the back, there will be no center, and then it is at the base. So anyhow, like it is quite confusing, students get confused in that if I'm saying that face centered but at the alternate, so if I'm saying like in this ki alternate face pe honge, so they think that ki alternate, that means total is 6, so alternate if we consider, they will consider the 3 particles, and that there the mistake is, they do the mistake over there. If I'm talking about the alternate phase, that means only 2, not 6, not 3. Got it? Alternate phase will be only 3, only 2, not 3. Okay, that is the point to be considered. Okay, so come to the point over here that we have done, that is I have explained. Next is this is the body center, so this one is not required over here now. Let me erase this. Okay, so body center, as I told you, that body center, that means along with the corner, one particle is in the center. Here it is made like this, so it doesn't mean that they are not. It is assumed, and you have to assume that because it is solid particles, so all the particles should be in very close with each other. Okay, so what we have to assume, that we have to think of that all the particles are touching each other. Coming to see this, you can say that ma'am, they are not touching, but actually these are touching. Like this is the actual 3D picture. All the particles, this is touched with this one is touching with this, every particle are touching with each other. Okay, chaliye. Now the face centered ka matlab along with the corner, in every face it will be like this is the face, one face, you can see. Yes, this one is the another face, this one is the third face in the center, this one is the back side face, fourth. Yes, this one is the front one face, 5, and here this one is the side face in the center. So 6 face, so 6 face center will be like center in the center of the face will be their particle. Okay, this is the end center. End center ka matlab kya hoga? Or we can say that either on this one is the example which I was explaining. We can say it as an end center, we can say as a base center, we can say as a alternate phase. Okay, it is at the alternate phase also. I hope it is clear. Any problem in this? Chalo. So if it is end center, so this is to be considered that if I'm talking about end center, that means 8 particles at the corner and only 2 particles which are at the face. Okay. Okay. So now let's do with the contribution of particles. What is the contribution of the particles? Whatever the corner particles are there, they have 1 by 8 contribution in one unit cell. Got it? Do I need to explain it, show it again? Let me show. If I'm doing this. So this is the 1 part, 1 by 8 part in one unit cell, isn't it? So that means you can say that one corner, this complete atom is like what we say, common in 8 unit cell. That I have already explained in the previous lecture. Yes. So here we can say that the contribution of one atom in one unit cell is just 1/8 of it. Yes. So that is the explanation over here. So now this is the point you have to learn, that primitive unit cell, if I'm talking about the corner unit cell, if I'm talking about the corner lattice, it will be the 1/8 contribution. Body center, complete body में एक पूरा atom होता है, isn't it? So body center, the contribution is just complete 1. Face centered, or you say that end center. You can say that the end center also. Okay. What will be the contribution of one atom? Half. That means half in one unit cell and half of in another unit cell. Got it? Clear? And center में भी वही होता है. Okay, one more thing is here that I have not explained over here. So you should know this edge center. If I'm talking about edge center, how many edges are there? Edges in the cube are 12. Okay, so let me draw this. If I'm drawing a cube like this, just assume that in the corner तो सारे particles हैं ही, but what I am doing, I'm going to explain only the edge. Okay, so let me do it this. That means how many edges are there? This is one edge. Yes, let me mark it 1. This is 2. This is 3. And this is 4. So at the top you can see 4. Similarly at the bottom 4. So top 4 हो गए, bottom 4 हो गए. Yes. And now check this one. So this is also 4. Yes, 1, 2, 3, 4. So in that one side 4. Yes. Will it be 4? See, this one is common, isn't it? This one is common in top and side. So what I will say, I will not write 4. Will simply write 3 over here. Okay. Similarly, in this also, this one is common. ये common हो गया. So there also 3. Now what next? Will it be 4? ये जो bottom को मैंने 4 लिखा. Will it be 4? Because see, this one already I have taken as a common. This one already I have taken as a common in this side one. So how many edges are there? Only 2. So total how many edges? 12 edges. Any problem in this? Clear a concept? So there are the 12 edges. Okay. So if the lattice site is in between, in the center of the edge, that means the particle is going to be like this. Okay. So what will be the contribution of this edge in one unit cell? Think of it. This unit cell is in common in 4 unit cell, isn't it? एक इसके ठीक पीछे होगा और 2 इनके ठीक ऊपर जो होगा, इनमें ये common होगा. So this edge length is in common in 4 unit cell. So what will be the contribution of edge centered lattice? If I'm talking about edge centered, what will be the contribution? Think of it fast. Yes, it will be 1 by 4. Isn't it? Any problem in this? Clear, Abhichi? Okay. So this contribution you have to learn. Then only you will be able to make the formula. Like we have to solve some question based on this. So for this you have to learn this contribution. Okay. Chali. So now how many unit cell, how many atoms will be there in the each type of unit cell? Let me talk about this. Primitive unit cell, only at the corner particles are there. Yes. So corner particles total, how many corner are there? 8. And what is the contribution of each corner particle? 1 by 8. So in the primitive unit cell, the number of atom will be considered as 1. And this is also called as rank. In somewhere you can see that the rank, ये rank से भी समझे जाते हैं, okay? And that can be represented as Z. Okay, so number of atom in a unit cell is known as rank, and that is represented by Z. So if I'm talking about the primitive unit cell, 8 corners are there and each corner has contribution 1 by 8, so it will be 1. Clear? If I'm talking about BCC, the corner particles are not going anywhere, the corner will be there like this, and there is one particle in the center, and that contribution is complete 1. So 1 into 1, that means it is 2. Is it clear? So what is the Z for BCC? 2. What is the rank for BCC? 2. Got it? Now come to the point FCC. FCC I'm talking about, this is not going to change. It will remain like that. 1 by 8 into 8, yes. Now, how many faces are there? 6. And each face centered particle has contribution 1 by 2. So total karoge, you will get that 4. Okay. Sometime it is, I am going to explain it. FCC is also known as CCP, cubic closed packed structure. And how it is, that I am going to tell you, I will explain later on. So somewhere it is CCP written, formula is written CCP. So here also understood that what is the rank over here? That is the 4. Clear? Any doubt in this? Okay. If I'm talking about the edge-centered unit cell, edge-centered cubic unit cell, if I'm talking about, sorry, edge-centered होना चाहिए. This is, I'm writing like ECC. समझ में आ रही बात? जैसे ये है वैसे. So here, how many edge particles are there? 12. And what is the contribution in this? Tell me contribution of one edge center particle, 1 by 4. Yes. And corner will to remain like that. So what it is? Isn't it? So total is equal to 4. So here also the number of atom will be 4. Either we are talking about CCP, or we are talking about FCC, or we are talking about ECC. In both the case, the rank will be 4. Clear? And the ratio of the number of particles A and B gives the formula of the compound. Kaise? We have some questions, so we will solve this question also. Okay, so let's do some question based on this. The first question is here on your screen, that is, a compound is made up of 2 types of atom, A and B. A is at all the corners and B is in the center of the body. Find the formula of the compound. Tell me fast, what will be the answer? So easy question. Yes, A is at the corner, so total number of particles are 8 and contribution is 1 by 8, so number of atom will be 1. Clear? And B is in the center of the body, so number of atom is 1. Because one particle in the center and the contribution is 1, so it will be 1. What will be the formula? जो भी ये ratio है, that will give you the formula AB. Got it? Let's do another question. A compound is made up of 2 type of atoms, X and Y. X is at all the corner and Y is in the center of the face. So X तो obviously 1 हो गया. Yes, quite clear. And Y is in the center of the face. That means center. How many faces are there? 6. So 6 and contribution is 1 by 2. So we will do, and we'll get the AB3. Any problem in this? So let's move to next question. Next question is that a compound is made up of 2 type of atom, X and Z. X is forming a primitive unit cell. That means it is at the corner, so X will be 1 for sure. Z is in the faces, and particles along one axis is removed. Think of it that all the Z are in the face. Okay, the particles along one axis. If I'm going to one axis, that means I'm going to cross 2 faces, isn't it? Yes. So if that means one axis removed, that means 2 particles are going to be removed from 2 faces. So if you see that X will be 1 by 8 into 1 by 8, that is quite clear. Z in the face, so number of atom 3 should be hona chahiye tha, but since the particle through one axis is removed, axis अगर remove हो तो that means it is crossing the two faces at least, hence the two particles will be removed from the face. Quite clear? So earlier it was 6, now to remove the 4. So what will be the formula? 2. And that means the compound should be the formula will be x1 z2, not xz3. Clear? So this is the answer. Now the next question. A compound is made up of three types of atom X, Y, and Z. X is forming a primitive unit cell. That means quite clear. X will be 1. Y is in the alternate phase. I have explained about that alternate phase. That means how many phases we have to consider? Only 2. Yes. And Z is in the center of the body. So let's do. X is at the corner. So number of atoms will be 8 into 1 by 8. That is quite clear. No issue in this. Now alternate phase. So number of particles will be, number of particles will be, this one is the, okay, alternate phase. So number of particles will be, atom will be 1 by 2 into 2, because how I have explained that alternate phase, whenever we talk about it will be only 2. Yes, 1. And Z is in the center of the body. So that means, this will be 1 only. Na? Center, yeah, this is wrong. It will be 1 into 1. Yes, 1 into 1 simply. So what will be the answer? 1 only, and that means the compound formula will be xy1 z1 yani xyz. No issue in this? Yes. Chaliye, next question. And that is a compound is made up of made up of three type of atom x, y, and z. X is forming a primitive unit cell. That means 1. Y is in the center of the face. That means 6 होते हैं. 6 divided by 1 by 2 तो 3 होना चाहिए. Z is in the center of the edge. Okay. If the particles through one axis is removed, again the same case, but यहाँ पे एक z axis भी डाल दिया, मतलब z particle भी डाल दिया. तो let's do this. X corner पे है, so there is no going, it's not going to remove anything. So that means 1. Clear है. Y is in the center of the face, so it should be 1 by 2, 6. 1 by 2 is the contribution and 6 is the number of particles present on each face. So it should be 3. But since through one axis is removed, that means what? One axis is removed, that means two face centered particles are going to be removed. So it will be 1 by out of 6, 2 will be removed, so it will be 1 by 2, 4 is equal to 2. So hona chahiye 3, but it won't be 3, it will be 2. And Z is in the center of edge. Edge, I have told you how many edge are there? 12. And each edge centered particle has contribution 1 by 4. So that's why 3. So answer will be x, y, 1, y2, z3, and x2, y2, z3. Got it? Any doubt in this? And the next question is, a compound is made up of two type of atom, P and Q. P is at each corner, Q is at alternative edge. Okay, so think of it. P, so it's quite clear, 1 ho gaya. Q is at alternative edge. If we talk about alternative edge, it will always be 4. Ye yaad rakhna hai aapko. Let me draw this. Alternative phase, if I'm talking about, it will be 2, and alternative edge, if we'll talk about, it will be always 4. Okay, how? Let me show you. ये understood करने के से, ठीक है? And here, the particle is going to be at kept on this edge center. So let me put this one over here. Okay, so it should be like alternate. Wherever in which direction you go, it should be alternate. Okay, so I am keeping 1 here. So if I am checking this face, ये ऊपर का face check करती हूँ. So this छोड़कर, that should be the alternate, isn't it? If I am going in this way, then also it is like this. Okay, if I am going like now, next one is here. This is the alternate face. इसको छोड़ के here it should be. Okay, and if in this, it should be this. अभी देख लो, everywhere it is alternate. If I'm checking, leave this one, leave this, and this is on this edge. In this way also, it is leaving this edge and here. And if I'm checking this, like इस वाले edge को check करती हूँ, so you'd see here I'm leaving it, and then on this edge. Yes, everywhere it is at the. In this also, this one I am leaving. For this also I am leaving this and here. So this is the 4 particles will be at the alternative edge. Whenever it comes for the alternative edge, it will be 4, and for face it will be 2. So let's solve this question. P is at the corner, so number of particle atom will be 1 by 8 into 8 like this, and alternative A edge, so that means 1 by 4, 1 into 4 is equal to 4. Clear hai? Alternative edge, sorry, this will be 1 by 4 because we know that the contribution of the edge particle is 1 by 4. So what it will be? It will be 1 only. Clear? So what will be the formula of the compound? P1Q1. Yani ki this will be PQ1. Is there any problem? Hope it is clear. Yes. Okay, so that's it. That's all about the question based on this topic. And next topic is closed packed structure. We are going to enter in the solid structure, solid crystal. So there we will understand that how the crystal lattice are there, how the arrangement of the particles are there, how they make the solid structure. So that we will do, and that is in next class. So till then, thank you class. Enjoy your study. Thank you.